like they hide the erasers. Okay, there's 4 annoying derivatives to do. Product rule, quotient rule, chain rule. All right, let's do them so we can move on to other kinds of problems. So you should expect on the exam to have to do a bunch of derivatives. So if you can do stuff like this, you'll be in good shape. So look at a problem like that. You say, all right, I know it's product rule because I have a function multiplied by another function. And the derivative of each of these is going to require the chain rule. So it tests both things at once. So if you want to find the derivative, so little stuff that you can do to annoy your TA. You don't write dy dx, you just write equals. And your TA will say, but it doesn't equal that. The derivative equals that. So make sure you have lots of time. Make sure you're being very careful how you lay out your answers. Okay? When you do your exams in pen, many of you make a huge mess. If you know you're one of those, do your exam in pencil. Okay? It becomes very difficult to follow what we're thinking sometimes, otherwise. All right, so leave the first function alone and multiply by the derivative of the second function. So remember, you bring down the 3 and make this to the 2 times the derivative of the inside. Plus, I'm probably going to run out of room, but now we have to go the other way. Now you leave the second equation alone. We'll squeeze the font a bit. And times the derivative of this one. So bring down the 2, that equation to the 1, times the derivative of that, which is 3x squared plus 4. Okay? Were you able to do that? So there's 2 components to this. One is you demonstrate the product rule. The other is you demonstrate the chain rule inside the product rule. Okay. This is quotient rule, but no chain rule, just quotient rule. So remember what you do. It is the bottom function times the derivative of the top function minus top function times the derivative of the bottom function. And then the whole thing is over the bottom squared. Okay? 2 for 2? Good. All right, third. This is also chain rule. So one thing you could do is you could rewrite this to the 1/2. Okay? The derivative is 1/2. Leave the inside alone. To the minus 1/2. What's the derivative of 1 over x? Negative 1 over x squared. So negative 1 over x would be positive 1 over x squared. Good? Okay, one more. So this is quotient rule again, and inside the quotient rule you have to do chain rule. So this is a messy one. Lots of stuff to write. Okay, and there's a long fraction bar. Bottom function times the derivative of the top. The top is 3 x to the fourth plus 2x plus 1 squared times 4x cubed plus 2 minus, other way around, x to the fourth plus 2x plus 1 cubed times the derivative of the bottom, which is 2 x squared minus 5 to the 1 times 2x. The whole thing, in the bottom, the whole thing is squared, so that becomes x squared minus 5 to the fourth. Okay? How are we doing that? Feeling good about those? Okay, that makes me happy. Let me give you another type of question in a second. We have more derivatives. How about that one? Relatively simple. Okay, how do you do the derivative of a log? And what you do, you write a fraction bar. The function goes in the denominator because it's 1 over that. And the derivative goes up top. That's all you have to do. That was easy, right? And e is even easier. So when you do the derivative of e to the something, you leave the e alone. It stays. And then you multiply by the derivative of the inside. So you should be able to do those kind of problems very quickly. Okay. How about this? Okay. Find the equation of the tangent line to y equals the square root of dx plus 3 and x equals 0. This is calculus class. You only know a couple things. So if you see a problem like this and you're not sure what to do, well, you're going to need to do the derivative because that's how you find slopes of tangent lines. So, because you can use the equation y minus y1 is the slope times x minus x1. You know x1 is 0. You're going to find y1, and then you find the slope by taking the derivative. So first, let's find y. So at 0, you get the square root of e to the 0 plus 3. What is e to the 0? 1, because anything to 0 is 1. So it's the square root of 4, which is 2. So we know this is y minus 2 equals slope times x minus 0, or just times x. All right. Now let's find the derivative. dy dx equals, so this is e to the x plus 3 to the half. So it's 1/2. E to the x plus 3 to the minus a half times e to the x. Or in other words, e to the x over 2 radical e to the x plus 3. So at x equals 0, get e to the 0, or 2 radical e to the 0 plus 3. That's 1. And this is 2 times 2. So it's 1/4, or a quarter, as they say in Brooklyn. So this is y minus 2 equals 1/4 x. And you can leave it like that. You don't need to make it 1/4 x plus 2 or anything fancy. So far, so good? Okay. Okay. Fine. The x value. Any maximums or minimums. Maximum and minimum values. In other words, x coordinates and then y coordinates. And on what intervals y increasing or decreasing. Okay, so another derivative. So let's take a derivative of this. We want to find where it's increasing, that would be where the derivative is positive. You want to find where it's decreasing, would be where the derivative is negative. Potential maximums and minimums will be where the derivative is 0. They're called critical values. So let's see. We get 3x squared plus x minus 2. Then we're going to want to set that equal to 0. Minus 2 plus 1. That works. So you get x equals 2/3. X equals -1. Make a number line. Put the appropriate values on the number line, -1 and 2/3. And now test values in each region and see whether the derivative is negative or positive. You check them by plugging back into the derivative. So you check a number less than -1, like -2. That comes out negative, that comes out negative. So curve's going up there. Try a number between -1 and 2/3, like 0. And you get a negative times a positive. So this is negative, so it's going down. So that's the maximum. And then try a number bigger than 2/3, like 1. And when you plug in, you'll get positive. So that will be a minimum. So let's see. X values of any maximums or minimums. These are the x values. And you have a max at x equals -1. You have a minimum at x equals 2/3. To find the y value, you take -1 and you plug it back into the original equation. And you get 7.5, you get 15/2. And 2/3 is a little annoying. You get 8/27 plus 4/18 plus 2/18, which is 16 plus 6 is 22/54 minus 4/3, which would be minus 72. So I'm getting a little lost, but minus 50/54 plus 5, which is 270. So I think you get 220/54. Or 110/27. Something like that. You can check, I could be wrong. That's how I keep the Alzheimer's away. I do that stuff in my head. And then where is it increasing or decreasing? Well, it's increasing. X x is less than -1 or x is greater than 2/3, and it's decreasing when x is between -1 and 2/3. Yes, you can write that in interval notation, but you don't have to. So far, so good? Let's see what other derivative stuff we can hit you guys with. Oh, right. We didn't do definition of derivative, did we? We did that last class. We did. Okay. Give you one more of these. Okay, so let's see. Let us find the x-coordinates of any maximums or minimums, the x-coordinates of any points of inflection, the intervals. So notice I'm not asking you for the y-coordinates. The intervals where it is increasing and decreasing. And the intervals where it's concave up and concave down. Derivative. The derivative is dy dx is 6x squared minus 6x minus 36. Set it equal to 0. So you can divide that through by 6. And you get x is 3. X is -2. So if you were finding y values, you have to remember to go and plug back into the original equation. Okay? But for the derivatives, since you're just trying to find the derivative of 0, you can get rid of the 6 and make your life easier. So that means we're going to have -2, 3, and you test some values, and you'll find that it goes plus minus plus. So it goes up, comes back down. That makes it a maximum, because you go up and you come down. And it goes down and comes back up, so that makes it a minimum. Okay? So let's do the second derivative. Second derivative is 12x minus 6, set equal to 0. You get x equals 1/2. Pick a number less than 1/2, this comes out negative, and greater than 1/2, that comes out positive. So concave down, concave up. I know I'm doing it a little fast, but I want to make sure we get it in. Okay, so that means we have a maximum at x equals 2, minimum at x equals -3. I'm sorry, -2 to +3. A point of inflection at x equals 1/2. It is increasing when x is either less than -2 or x is greater than 3. It's decreasing when x is between those. It is concave up x is greater than a half, and concave down when x is less than a half. All right, more stuff to review on Friday. Take a picture of that.